Yes, hello students. Welcome to my channel Sri Vlogs Fun and Edutainment. So today we are going to discuss one most important topic of Unit 3 in our MNC subject. So in this Unit 3 we will going to discuss mean value theorems, right? So there are three mean value theorems. One is Rolle's theorem. Second one is Lagrange's mean value theorem. Third one is Cauchy mean value theorem. Let us try to discuss these three mean value theorems if possible, right? So first we are going to discuss Rolle's theorem, right? Rolle's theorem. So coming to Rolle's theorem, the statement is let f of x be a function such that here, Rolle's theorem should satisfy three conditions. What are the three conditions? Rolle's theorem must satisfy three conditions. So, first condition is it is continuous. It is continuous in closed interval a comma b. So, this is what closed interval a comma b. It is differentiable. It means here the function f of x, right? f of x is continuous in closed interval a comma b, and f of x is differentiable in open interval a comma b, and f of a equal to f of b. Then there exists at least one point c in open interval a comma b such that f dash c is equals to 0. Okay, this is what Rolle's theorem statement. So first is continuous in closed interval a comma b and differentiable in open interval a comma b, and the third condition is very important, f of a is equals to f of b. Then there exists at least one point c in open interval a comma b such that f dash c is equals to 0. Let us try to do one problem on Rolle's theorem. Okay, the geometrical interpretation is also there, but we don't need the geometrical interpretation. In our syllabus, geometrical interpretation is deleted. So here, so according to the nature of the function, we will do the first two conditions. So every polynomial function is continuous in closed interval a comma b. That means whenever polynomial is given to us, then there is no need of checking for continuity because every polynomial is continuous in the given interval and also differentiable in open interval a comma b. So if the given function is a polynomial function, what is meant by polynomial? Polynomial is nothing but here x cube minus 3x square plus 2x plus 1. You have learnt about polynomials in your 10th class level, right? This is a polynomial x cube minus 3x square plus 2x plus 1, which is a polynomial of degree 3. So what is meant by degree? The highest power of the variable is denoted by the degree. So what is the highest power in this expression? 3. So this is a third degree polynomial, right? So whenever the powers contains only positive values, positive integers, then this is said to be the polynomial. Okay, here the leading power of x is 3, here 2, and here it is 1. There is no power, means x power is 1 here, and here x power 0. Okay, x power 0 is nothing but a constant. So clearly it is a third degree polynomial, right? So if the function is given like this, then there is no need of verifying is it continuous or not. Okay, because it is always continuous in closed interval a comma b. Every polynomial is continuous in closed interval a comma b, and every polynomial is differentiable in open interval a comma b. So sometimes the function given like this, composite functions, that means standard functions, e power x, log of sin x, sin inverse x, these are some standard functions. If these functions are given, we need to check either the given function is continuous or differentiable in the defined interval, right? Now we will go to the problem. So this is the problem. Verify Rolle's theorem. Verify Rolle's theorem for following problems. What is the function here? It is the first problem. F of x is equals to x plus 2 whole cube into x minus 3 whole to the power of 4. Okay, f of x is equals to x plus 2 whole cube into x minus 3 whole to the power of 4. So if we multiply this x plus 2 whole cube into x minus 3 whole to the power of 4, sure we will get a polynomial. What type of polynomial is this? What degree polynomial here? Highest power. Highest power in this expression is x to the power of 3. If we expand x plus 2 whole cube, we get the highest power of x is x cube. Okay, if we expand this one, we will get x to the power of 4. That means this is 3 plus 4, 7th degree polynomial. So already we have discussed every polynomial is continuous and differentiable in the given interval. What is the interval given here? A comma b is equal to minus 2 comma 3. That means a is equals to minus 2 and b is equals to 3, right? So a is equals to minus 2. When we compare, we will get a equals to minus 2 and b equals to 3. Okay, now f of x is a polynomial in x, hence it is, you can directly written as continuous in closed interval minus 2 comma 3. Now for differentiation, we can do the differentiation first. F dash x is equals to, f dash x is nothing but both sides we are doing differentiation for this function f of x. Okay, d by dx of f of x is nothing but f dash x, right? So f dash x is equals to d by dx of x plus 2 whole cube into x minus 3 whole to the power of 4. How do we differentiate this expression? Right, doing the, this is the u into v formula. There are two functions here. Okay, two functions. One is x plus 2 whole cube and other one is x minus 3 whole to the power of 4. Okay, so we need to apply uv formula. uv formula. U, this is u and this is v. This is v, right? So what is the formula for uv? V into du by dx plus u into dv by dx. According to that, we get x minus 3 whole to the power of 4 into x plus 2 whole to the power of 3, n into x to the power of n minus 1 formula. Using n into x to the power of n minus 1 formula, we get 3 into x plus 2 whole to the power of 3 minus 1, that is 2, plus x plus 2 whole cube into, that means u into x minus 3 whole power 4 differentiation, 4 into x minus 3 whole to the power of 4 minus 1, that is 3. Okay, now we can take common in these two terms. If we observe here, x minus 3 whole to the power of 4 is there, here x minus 3 whole cube is there. So you can take common x minus 3 whole cube, right? And here it is x plus 2 whole square, and here it is x plus 2 whole cube. So you can take common x plus 2 whole cube. So taking common x plus 2 whole cube into x minus 3 whole cube, we get it as 3 into x minus 3 in the first term, plus in the second term 4 into x plus 2. Okay, so x plus 2 whole square into x minus 3 whole cube of, after calculation we get it as 7x minus 1. Okay, so f dash x exists on my open interval minus 2 comma 3. So derivation is exist. So in the given interval differentiation exists. So now what is the third condition of Rolle's theorem? F of a equals to f of b. F of a equals to f of b. What is a here? Minus 2. A is minus 2, right? Here a is minus 2. So simply we need to substitute a value in the function and b value in the function. After substituting a value and b value in the given function, what we get? F of minus 2 is equals to x plus 2. Minus 2 plus 2, that is equals 0. F of 3, that means x plus 2 into x minus 3. x minus 3 kada. Here x minus 3 is there. So x minus 3. In the place of x, if we substitute 3, 3 minus 3, that is equal to 0. Therefore, f of minus 2 is equals to 0 is equals to f of 3. That means third condition is also satisfied. F of a equals to f of b. Therefore, thus all the three conditions of Rolle's theorem are satisfied. Clear? So we need to prove there exists at least a point C in minus 2 comma 3, open interval minus 2 comma 3, such that f dash c is equals to 0. F dash c is equals to 0. So first we need to write in the place of x c here in this expression. In the place of x we need to write c. So when we write c, then what we get, f dash c is equals to c plus 2 whole square into c minus 3 whole cube into 7c minus 1. Okay. So c plus 2 whole square not equals to 0, because if c equals to minus 2, the function is equals to 0. And yeah, c plus 2 whole square is equals to 0, and c minus 3 whole cube is equals to 0, and 7c minus 1 is equals to 0. If c plus 2 whole square is equals to 0, what we get, c is equals to minus 2. C minus 3 whole cube is equal to 0, what we get, c is equals to 3. And 7c minus 1 is equal to 0, what we get, c is equals to 1 by 7. But c is equals to minus 2 and 3 does not belongs to open interval minus 2 comma 3. Therefore, these two values are not belongs to that. And c is equals to 1 by 7. C is equal to 1 by 7 clearly belongs to minus 2 comma 3. It is in between the interval minus 2 comma 3, because minus 2 less than 1 by 7 less than 3. Hence, Rolle's theorem is verified. So, this is about Rolle's theorem. This is the way of doing the problems of Rolle's theorem. Okay, now? So, one more problem I have given it in this PDF. F of x is equal to 2x cube plus x square minus 4x minus 2. So, please try this problem on your own. This is also polynomial. And I have given one more problem. F of x is equal to x cube in 1 comma 3. This is also polynomial. So let us try this type of problems. Okay, I have given solutions also, right? So now we move to the next theorem, which is called Lagrange's mean value theorem. Okay, Lagrange's mean value theorem. Lagrange's mean value theorem, right? What Lagrange's mean value theorem states? The statement is, let f of x be a function such that, same as like Rolle's theorem. Number one condition, it is continuous in closed interval a comma b, differentiable in open interval a comma b. These two conditions are similar as far as Rolle's and Lagrange's concerned. In Lagrange's theorem, the basic difference between Rolle's theorem and Lagrange's theorem is third condition. There is no need of third condition in Lagrange's theorem. Lagrange's directly says that then there exists at least one point C in open interval a comma b such that, this is very very important, such that f dash c equals to f of b minus f of a by b minus a. So what is the basic difference between Lagrange's and Rolle's? Rolle's says that f dash c is equals to 0. Okay, f dash c is equals to 0. But Lagrange's says that f dash c is equals to f of b minus f of a by b minus a. So this is what the basic difference between Lagrange's theorem and Rolle's theorem. Now we need to find the c value using this condition. F dash c is equals to f of b minus f of a by b minus a. The same function, according to the function, we will verify the conditions, right? Now we move to the problem. Geometric interpretation is not needed. So now coming to the Lagrange's theorem, one problem is given here. So problem, verify Lagrange's mean value theorem for the following problems. So this is the first problem. F of x is equals to x cube minus x square minus 5x plus 3 in 0 comma 4. The interval is given, right? So what is given first? F of x is equals to, write the given function, x cube minus x square minus 5x plus 3. Write the given interval. a comma b is equals to 0 comma 4. That means when comparing, we get a equals to 0, b equals to 4. Okay. So now f of x is a polynomial. Clearly already we have discussed what is a polynomial. F of x is a polynomial in x. Clearly it is a third degree polynomial. So every polynomial is continuous in the given interval. Okay. So in the given closed interval 0 comma 4. Now f of x is equals to, if it is differentiable or not, we need to find the differentiation. Now we are taking f of x is equals to x cube minus x square minus 5x plus 3. Now we are doing differentiation on both sides. So d by dx of f of x, that is equal to d by dx of x cube minus x square minus 5x plus 3. All we know that d by dx of x cube is 3x square, and d by dx of x square is minus 2x, and d by dx of minus 5x is minus 5, and d by dx of 3 constant differentiation is 0. No need of writing. Okay. So this is f dash x. F dash x is equals to 3x square minus 2x minus 5. That means it is clearly exists. F dash x exists. Therefore f of x is differentiable in 0 comma 4. Right. Now what Lagrange stated, if there exists at least one c belongs to open interval a comma b such that f of b minus f of a by b minus a. So that we are finding first f of b minus f of a by b minus a. So that for we are finding f of 4 because the b value is 4. So f of 4. F of 4 is nothing but we need to substitute 4 in the place of given function. In the 4 in the place of x in the given function. So 4 cube minus 4 square minus 5 into 4 plus 3. Okay. That's what I wrote here. 4 cube minus 4 square minus 5 into 4 plus 3. That is equals to, while calculating, it is 31. And f of 0. So put x is equal to 0 in f of x, then we get it as 3. Okay. Now we are finding f of b minus f of b minus f of a by b minus a, that is equal to f of 4 minus f of 0 by 4 minus 0. So already we have found that f of 4 value is 31, f of 0 value is 3. Therefore 31 minus 3 by 4, that is equals to 7. This is the value of f of b minus f of a by b minus a. Now what Rolle's Lagrange stated, f dash c is equals to f of b minus f of a by b minus a. Okay. Now f dash c is nothing but in the place of f dash x we need to substitute in the place of x c. Okay. So 3c square minus 2c minus 5. So in the place of f dash x, this is f dash x, we have to substitute x is equals to c. Then we get it as 3c square minus 2c minus 5, that is equal to 7. Okay. Now 3c square minus 2c minus 12 is equals to 0. After solving using Cauchy, we get c is equals to 1 plus root 37 by 3, that is approximately 2.36, and we get 1 minus root 37 by 3, that is equals to approximately minus 1 plus 0.69. Now this minus 1.69 does not belong to 0 comma 4. Clearly this 2 comma 3 clearly belongs to 0 comma 4. Hence one value belongs to 0 comma 4. At least one value belongs to 0 comma 4. Hence Lagrange's mean value theorem is verified. So in this way we do the Lagrange's mean value theorem problems. Okay. I have given some more problems. Please try these problems. Right. F of x is equal to x into x minus 2 into x minus 3 in 0 comma 4. Right. So there are some inequality problems in Lagrange's mean value theorem. We do these problems by using Lagrange's theorem. Okay. So this is the problem given to us. If a less than b, prove that b minus a by 1 plus b square less than tan inverse b minus tan inverse a less than b minus a by 1 plus a square, using Lagrange's mean value theorem. Hence, deduce pi by 4 plus 3 by 25 less than tan inverse 4 by 3 less than pi by 4 plus 1 by 6. This is very, very important problem. So first we need to prove this inequality using the Lagrange's theorem. We need to prove this inequality using Lagrange's theorem. Afterwards, we need to deduce this inequality. Okay, so for this type of problems, first we need to observe what is the trigonometric function given. Okay, here tan inverse b minus tan inverse a exists in the inequality which is given to us. We need to prove that. So we need to take f of x. We need to consider f of x is equals to tan inverse x because tan inverse b minus tan inverse a are there in the inequality. So we take f of x is equals to tan inverse x in closed interval a comma b for 0 less than a less than b less than 1. This is also given in the problem, right? Now using Lagrange's theorem, what we know, f dash c is equals to f of b minus f of a by b minus a. Now what is f dash c? Because the differentiation of tan inverse x is equals to 1 by 1 plus x square. Okay, f of x differentiation, all we know that 1 by 1 plus x square. So in the place of x, if we substitute c, we get 1 by 1 plus c square is f dash c. 1 by 1 plus c square is equals to f of b minus f of a by b minus a is nothing but tan inverse b minus tan inverse a by b minus a. Okay, this is the condition number 1. Now clearly we know that a less than c less than b. Okay, according to Lagrange's theorem, at least one c belongs to open interval a comma b. Therefore a less than c less than b. This is the inequality we get from Lagrange's mean value theorem. Now what is there here? Here 1 plus c square is there. Okay, here 1 plus c square is there. So we need to square this inequality and add 1. Then we get it as 1 plus a square less than 1 plus c square less than 1 plus b square. But what we are having here, 1 by 1 plus c square. So we need to get 1 by 1 plus c square. So whenever the value is in the denominator, the inequality must be changed. So when less than, if we convert it into the denominator, it will be greater than. If it is less than, if it is greater than when we convert it into the denominators. Okay, so 1 by 1 plus a square greater than 1 by 1 plus c square greater than 1 by 1 plus b square. So according to our convenience, we are writing because we need to prove 1 by 1 plus b square here, 1 by 1 plus a square is also there. So we are writing it as 1 by 1 plus a square greater than 1 by 1 plus c square value already we know. This is the value. Tan inverse b minus tan inverse a by b minus a greater than 1 by 1 plus b square. Now b minus a by, using the cross multiplication, we cross multiply this b minus a. B minus a by 1 plus a square greater than tan inverse b minus tan inverse a greater than b minus a by 1 plus b square. Now b minus a by 1 plus b square. Now we are writing the total inequality in the reverse order. So when we write it in the reverse order, greater than must be into the less than. Okay, transforms to less than. Therefore, b minus a by 1 plus b square less than tan inverse b minus tan inverse a less than b minus a by 1 plus a square. First inequality we proved. Okay, we proved the first inequality. Now hence deduce. Now to deduce the values, clearly what we need to prove? Tan inverse 4 by 3. So in the place of b we need to substitute 4 by 3 and in the place of a we need to substitute 1 because tan pi by 4 is equal to 1. Here pi by 4 is appears. Therefore a equals to 1. So we need to observe this. So in the place of b we are substituting 4 by 3 in the above inequality and in the place of a we are substituting 1 in the above inequality. After calculating this inequality carefully we will get clearly this one. Hence deduction, right? In the second one we need to substitute b is equal to 2 and a is equal to 1. Clear all of you? Right. Now there is another mean value theorem that is called Cauchy's mean value theorem. Okay, we move to the next mean value theorem, Cauchy's mean value theorem. What Cauchy's mean value statement. So this is the statement. If f maps to closed interval a comma b tends to r, g maps to closed interval a comma b tends to r. So here two functions are there. F g are continuous on closed interval a comma b Fg are differentiable on open interval a comma b, and g dash x not equals to 0 for all x belongs to open interval a comma b, then there exists a point c belongs to a comma b such that this is very important condition, f dash c by g dash c is equals to f of b minus f of a by g of b minus g of a. This is what the Cauchy mean value theorem. Now we will do one problem on Cauchy mean value theorem. Find C of Cauchy mean value theorem using Cauchy mean value theorem for f of x is equals to root x and g of x is equal to 1 by root x in closed interval a comma b, where 0 less than a less than b. So clearly fg are continuous on closed interval a comma b because they are subset or R place, right? We have f dash x, root x differentiation is 1 by 2 root x, g dash x 1 by root x differentiation is minus 1 by 2 into x to the power of minus 1 by 2 minus 1, all you know that in your intermediate level, minus 1 by 2x into root x. Okay na? Right. So f comma g are differentiable because there is no 0 less than a less than b. If 0 is there in the interval, then g dash x does not exist, f dash x does not exist, but 0 is not there in the interval. Clearly it is given that 0 less than a less than b. Okay, so now using the condition g of f of b minus f of a by g of b minus g of a is equals to f dash c by g dash c, we substitute and calculating the values, we get c is equals to root ab. Clearly root ab always lies between a comma b. If you take any example 1 comma 2 or 2 comma 3, if you take 1 comma 2, root 2 lies between 1 comma 2. If you take 2 comma 3, we get root 6. Root 6 is always lies between a comma b. Okay, so this is what Cauchy's mean value theorem. So these three mean values theorem are very important. So one problem you will get in your final examination and some examination on the three mean value theorems. Mostly on Lagrange's mean value theorem you will get one long answer question in your final examination, especially the problems based on inequalities, right? Hope I think you understand well. Now this is all about today's class. Thank you very much. I'm leaving.